Question 1a. Define intensive property and extensive property. Intensive property is a property whose value does not depend on the mass of the system. Examples are pressure, temperature, and density. Extensive property is a property whose value depends on the mass of the system. Examples are volume, internal energy, enthalpy, and entropy. Question 1b. List any two assumptions for ideal gas. Assumptions for ideal gas are: gas contains a very large number of molecules in random motion. Volume of molecules is negligible compared with the volume occupied by gas. Collisions of molecules are perfectly elastic and intermolecular forces are neglected. Any 2 points are sufficient. Question 1c. Define dry saturated steam and wet steam. Dry saturated steam is steam at saturation temperature which contains no water particles. For dry saturated steam, dryness fraction X is equal to 1. Wet steam is steam containing water particles in suspended form. For wet steam, dryness fraction X is less than 1. Question 1d. State Dalton's law of partial pressure. Dalton's law of partial pressure states that the total pressure exerted by a mixture of non-reacting gases is equal to the sum of partial pressures of individual gases. Therefore, P is equal to P1 plus P2 plus P3 up to Pn. Question 1e. List any two applications of nozzle. Applications of nozzle are: it is used in steam turbines to convert pressure energy into kinetic energy. It is used in jet engines and rocket motors. It is also used in injectors and flow measurement devices. Any two applications are sufficient. Question 1f. Define thermal conductivity and state its unit. Thermal conductivity is the amount of heat conducted through a body of unit area and unit thickness in unit time, when the temperature difference between two faces is 1 Kelvin. Its unit is watt per meter Kelvin. Question 1g. Define compression ratio in internal combustion engines. Compression ratio is the ratio of total cylinder volume to clearance volume in an internal combustion engine. In other words, it is the ratio of volume when the piston is at bottom dead center to volume when the piston is at top dead center. The formula is R equal to V1 by V2 equal to Vs plus Vc divided by Vc. Question 2a. Differentiate between heat engine and refrigerator. See the table carefully. You will have to reproduce this comparison table in the exam. Observe the columns, point, heat engine and refrigerator. Focus on purpose, heat flow, work, performance and statement. Now let us read the answer. Heat engine converts heat energy into work, whereas refrigerator removes heat from low temperature space. Heat engine takes heat from source and rejects heat to sink, while refrigerator absorbs heat from cold body and rejects heat to hot body. Heat engine produces net work output, while refrigerator requires work input. Heat engine performance is measured by thermal efficiency, while refrigerator performance is measured by coefficient of performance. Question to be: 2 kg of gas at 50 degrees Celsius is heated at constant volume until pressure is doubled. Determine final temperature and change in internal energy. Given mass is 2 kg, initial temperature is 50 degrees Celsius or 323 Kelvin, final pressure is twice initial pressure and CV is 0.718 kJ per kilogram Kelvin. At constant volume, pressure divided by temperature remains constant. Therefore, T2 is equal to P2 by P1 multiplied by T1. Since pressure is doubled, T2 is 2 into 323 equal to 646 Kelvin or 373 degrees Celsius. Change in internal energy is mCV into T2 minus T1. Substituting values, delta U is 463.83 kJ. Question to C. Draw neat sketch of forced draught cooling tower. See the image carefully. You will have to reproduce this forced draught cooling tower sketch in the exam. Observe the fan near the bottom, air inlet, upward air flow arrows, eliminators at the top, hot water from condenser, makeup water, cold water circulation and water tank. The key point is that air is forced upward through falling hot water. Now let us read the answer. In forced draught cooling tower, fan is placed near the bottom and air is forced upward through falling hot water. Heat is removed and cooled water is collected in the tank. Question to D. Determine the rate of heat transfer through a composite wall. Given thickness of steel is 0.025 meter, thermal conductivity of steel is 58 watt per meter Kelvin, thickness of insulating material is 0.007 meter and its thermal conductivity is 0.116 watt per meter Kelvin. Temperature difference is 240 Kelvin. For composite wall per unit area, heat transfer rate is delta T divided by total thermal resistance. Substituting the values, Q by A is 3948.7 watt per square meter. Therefore, the rate of heat transfer is 3.95 kilowatt per square meter of wall. Question 3a. Explain Zeroth law of thermodynamics with suitable example. See the image carefully. You will have to reproduce this simple diagram in the exam. Observe body A, body B and body C. Body A is in equilibrium with body B and body A is also in equilibrium with body C. This shows the idea of thermal equilibrium. Now let us read the answer. Zeroth law of thermodynamics states that if two systems are each in thermal equilibrium with a third system, then they are also in thermal equilibrium with each other. This law forms the basis of temperature measurement. Question 3b. Represent isochoric and isobaric processes on PV and TS diagrams. See the image carefully. You will have to reproduce 4 small diagrams in the exam: PV and TS diagram for isochoric process and PV and TS diagram for isobaric process. For isochoric process, volume remains constant. In the PV diagram, this is shown by a vertical line. For isobaric process, pressure remains constant. In the PV diagram, this is shown by a horizontal line. Also observe the direction from state 1 to state 2. Now let us read the answer. Isochoric process means volume remains constant. Isobaric process means pressure remains constant. Question 3c. Differentiate between water tube and fire tube boiler. See the table carefully. You will have to reproduce this comparison table in the exam. Observe the columns: parameter, water tube boiler and fire tube boiler. Focus on medium in tube, steam formation rate, pressure, efficiency and examples. Now let us read the answer. In water tube boiler, water circulates inside tubes, while in fire tube boiler, hot gases pass through tubes. Steam formation rate is high in water tube boiler and low in fire tube boiler. Water tube boiler is suitable for high pressure, while fire tube boiler is generally for low pressure. Overall efficiency of water tube boiler is high, while fire tube boiler efficiency is comparatively low. Question 3d. Represent Otto cycle on PV and TS diagram. See the image carefully. You will have to reproduce both PV and TS diagrams of Otto cycle in the exam. Observe the 4 processes 1, 2, 2, 3, 3, 4 and 4, 1. Also observe that heat addition and heat rejection are at constant volume. Now let us read the answer. Otto cycle consists of 1 to 2 isentropic compression, 2 to 3 constant volume heat addition, 3 to 4 isentropic expansion, and 4 to 1 constant volume heat rejection. Question 4a. A gas is compressed at constant pressure. Determine work done in compression and heat given out by gas. Given volume V1 is 0.14 meter cube, pressure is 1.6 bar, temperature T1 is 383 Kelvin, and final volume V2 is 0.112 meter cube. At constant pressure, V1 by T1 is equal to V2 by T2. So T2 is 306.4 Kelvin or 33.4 degrees Celsius. Work done by gas is P into V2 minus V1 equal to minus 4.48 kJ. For air, mass is calculated using PV1 by RT1 giving 0.204 kg. Heat transfer is mCp into T2 minus T1 equal to minus 15.7 kJ. Therefore, heat given out by gas is 15.7 kJ. Question 4b. Define sensible heat and latent heat. Sensible heat is the heat supplied or removed which changes the temperature of a substance without changing its phase. Sensible heat is given by mCp into T2 minus T1. Latent heat is the heat required to change the phase of a substance at constant temperature. An example is latent heat of vaporization of water. Question 4c. Draw a neat sketch of surface condenser and label it. See the image carefully. You will have to reproduce this surface condenser diagram in the exam. Observe all labels: water inlet, water outlet, baffle plate, tubes, tube plate, exhaust steam and condensate to extraction pump. The main point is that cooling water flows through the tubes and exhaust steam passes outside the tubes. Now let us read the answer. In a surface condenser, exhaust steam passes over tubes carrying cooling water. Steam condenses on the tube surfaces and the condensate is removed by extraction pump. Question 4d. Define transmissivity and reflectivity. Transmissivity is the ratio of transmitted radiant energy to the total incident radiant energy on a body. It is denoted by tau. Reflectivity is the ratio of reflected radiant energy to the total incident radiant energy on a body. It is denoted by rho. Question 4e. Compare between petrol engine and diesel engine. See the table carefully. You will have to reproduce this comparison table in the exam. Observe the columns: petrol engine and diesel engine. Focus on working cycle, fuel, ignition, compression ratio, weight and speed, and thermal efficiency. Now let us read the answer. Petrol engine is spark ignition engine and diesel engine is compression ignition engine. Petrol engine works on Otto cycle, while diesel engine works on diesel cycle. Petrol and air mixture is used in petrol engine, while in diesel engine only air is compressed first. Petrol engine uses spark plug, while diesel engine uses self-ignition due to high compression. Petrol engine compression ratio is low, while diesel engine compression ratio is high. Question 5a. Write steady flow energy equation. State the meaning of each term and apply it to boiler, steam nozzle and steam turbine. Steady flow energy equation per kilogram is Q plus H1 plus C1 square by 2 plus GZ1 is equal to W plus H2 plus C2 square by 2 plus GZ2. Here Q is heat supplied, W is work done, H is enthalpy, C square by 2 is kinetic energy and Gz is potential energy. For boiler, no work is done and kinetic and potential energy changes are negligible. Therefore Q is H2 minus H1. For steam nozzle, no work is done, process is adiabatic and potential energy is neglected. Therefore H1 plus C1 square by 2 is equal to H2 plus C2 square by 2. For steam turbine, process is adiabatic and kinetic and potential energies are neglected. Therefore work output is H1 minus H2. Question 5b. Explain construction and working of Lamont boiler with neat sketch. See the image carefully. You will have to reproduce this Lamont boiler diagram in the exam. Observe the main parts: feed pump, economizer, air preheater, storage and separating drum, circulating pump, evaporator tubes, radiant evaporator, superheater, chimney blower and steam outlet. Notice the forced circulation path of water through evaporator tubes and return of steam water mixture to the drum. Now let us read the answer. Lamont boiler is a high-pressure water tube boiler with forced circulation. Its main parts are economizer, air preheater, circulating pump, evaporator tubes, drum and superheater. Water from drum is forced by circulating pump through evaporator tubes. The steam water mixture returns to separating drum. Steam is then superheated and supplied to turbine. Question 5c. State classification of heat exchangers. List any 4 applications of heat exchanger. Heat exchangers are classified according to transfer process as direct contact and indirect contact type. According to construction, they are tubular, shell and tube, plate type and extended surface type. According to flow arrangement, they are parallel flow, counter flow and cross flow. According to pass arrangement, they are single pass and multi-pass. Applications are automobile radiator, condenser coil in refrigerator, air conditioner, cooling tower, boiler economizer, oil cooler and intercooler. Any 4 applications are sufficient. Question 6a. Describe the formation of steam at constant pressure with the help of temperature enthalpy diagram. See the image carefully. You will have to reproduce this temperature enthalpy diagram in the exam. Observe the horizontal heat supplied axis and vertical temperature axis. Also observe the stages AB, BC, CD, DE and EF. The constant temperature portions represent latent heat and phase change, while inclined portions represent sensible heating or superheating. Now let us read the answer. During AB, ice or water is heated sensibly and temperature and enthalpy increase. During phase change, heat supplied is latent heat and temperature remains constant. During DE, water changes into steam at saturation temperature and wet steam changes to dry saturated steam. During EF, further heat produces superheated steam and both temperature and enthalpy increase. Question 6b. Explain the working of impulse steam turbine with neat sketch and show pressure and velocity variation. See the image carefully. You will have to reproduce two sketches in the exam: simple impulse turbine and pressure velocity variation diagram. Observe the nozzle, rotor blades, steam jet, diaphragm and casing. In the pressure velocity diagram, observe that pressure falls in the nozzle and velocity increases. In moving blades, pressure remains nearly constant and velocity decreases gradually. Now let us read the answer. Steam expands completely in the fixed nozzle, so pressure falls and velocity increases. High-velocity steam jet strikes the moving blades on rotor V. The direction of steam changes over the blades, producing impulse force and shaft rotation. In moving blades, pressure remains nearly constant, but velocity gradually decreases. Question 6c. Explain the working of 4-stroke petrol engine with a neat sketch. See the image carefully. You will have to reproduce the 4 strokes of petrol engine in the exam. Observe the 4 diagrams labeled suction, compression, expansion and exhaust. Also observe inlet valve, exhaust valve, spark plug, piston and crank motion. The important point is that one cycle is completed in 4 strokes and 2 revolutions of crankshaft. Now let us read the answer. During suction, air-fuel mixture enters the cylinder through inlet valve. During compression, the mixture is compressed with both valves closed. During power or expansion, spark plug ignites the mixture and gases push the piston down. During exhaust, burnt gases are discharged through exhaust valve.